Next, we want to talk about problems caused by imprecise directory information. That means that the entries in the directory don't actually need to be there, but they're there. Why? Why does directory information get stale over time? Well, the reason is that clean blocks are evicted from the cache without notifying the directory. Why are clean blocks evicted from the cache without notifying the directory? Well, the reason we don't notify the directory every time we evict a block is that most blocks evicted are clean. And so if we did notify the directory, it would cause a large increase in traffic. So we trade that problem off against a few other problems, and they're enumerated right here. First, increased power consumption and latency in locating a block. Second, storage overhead. Third, if the directory gets full because it contains these stale entries, then extra blocks need to be invalidated. And fourth, an increase in invalidation traffic. So let's consider each of these issues. Problem 1 is caused by 3 evictions. Now, I've got several questions on this, and I want to scroll down to the diagram so you can answer them while looking at the slide. Remember again that problem 1 is increased power consumption and latency in locating a block. So let's take a look at the diagram right here. Now let's look at the other problems. Problem 2 is storage overhead, and that's caused by unneeded directory entries taking up space in the directory. Which directory entries above are unneeded at the end of step 9? Now you can look at the directory entries that are crossed out here, and you've got the entry for B and those 2 caches and the entry for D there. And so you might think it's B and D, but actually it's not, because the entry for B is unneeded, but the entry for D is actually going to be needed in step 6, because remember that processor 1 reads D in that step, and so if the entry for D were not there, then it wouldn't know where to go. So it actually is needed. Now problem 3 is extra blocks invalidated when the directory gets full, and that also is illustrated in the diagram here. And in order to see where that is, so look at this eviction. It's not the eviction of a block, but rather the eviction of a directory entry. And so why is that directory entry being evicted? Well, it's being evicted because it's step 10, P2 read E, and so we need to find room in the directory for E, but the directory is full, so we need to evict an entry, so we evict the least recently used entry, which is the entry for C. And then that requires that C be evicted from P2's cache, because otherwise, you wouldn't be able to find where the memory backing it was. So this causes an unnecessary miss there. You have to throw away cache line C because you don't have room for its directory entry. So it's steps 11 and 12 that illustrate this problem. Now, how can this cause an unnecessary cache miss? Well, we have to evict block C from the cache simply because we don't have room for the directory entry. And if we didn't have the rule that we weren't getting rid of entries every time the block is removed, we probably wouldn't have a full directory, and so we wouldn't encounter this problem. Problem 4 is an increase in invalidation traffic, but overall traffic might not be higher when stale entries are allowed. And that is because keeping the directory up to date causes traffic too. So Solihin suggests 2 antidotes for this problem. First of all, aggregating notification messages on clean block purges. So you don't notify the directory every time, but the processor keeps track of it, and every once in a while it tells the directory which blocks are no longer needed on its account anyway. Other processors may still be sharing those blocks. Another way is to predict when directory blocks are invalid based on the number of misses from a particular last level cache.